everyone, welcome to our tutorial video. Today we're going to solve a real-life problem using a Python programming. So imagine this, you're at the airport with your mom and ready to travel abroad. Suddenly, you realize her passport is locked in a safe at your home. You have only 5 hours left before your flight and you need to open the safe using the brute force. So let's see how we can solve this problem step by step.
So, here's the situation. You and your mom are at the airport. She realizes her passport is locked in a safe at home. You rush back home, but the safe can only be opened with a combination. You don't have your phone or any way to contact your mom. The safe has a digital lock with numbers from 0 to 9. You need to try every possible combination to open it before your flight departs. And time is running out.
So to solve this problem, we have written a Python program that uses brute force to generate all possible combinations for the safe. So let's take a look at the code. The program asks for the number of digits in the combination, then generates and tests every possible combination until it finds the right one. So here how it works. So first, we import the time module to measure how long the program takes. Next, we ask the user for the number of digits in the combination and initialize a list called combination with zeros. Then, we set up a counter or count and a timer or a start to track progress. And after that, we enter a while loop that runs until all combinations are tried. And inside the loop, we increment the counter and print the correct combination. We use a for loop to update the combination starting the rightmost digit. And if a digit reaches 9, it resets to 0 and the next digit to the left is incremented. And then finally, when all combinations are exhausted, the program prints the total number of combinations and the time taken. Now, let me introduce a second code that is optimized for larger combinations like 10 digits. So here's the code. Let me briefly explain how this code works. So first, we ask for the number of digits and initialize a counter and timer. Then, we use a for loop to iterate through all possible numbers from 0 to 10 digit number. And inside the loop, we convert each number to a string and pair it with zeros using zfill to match the required digit length. And finally, we print the total number of combinations and the time taken. The key difference between this code and the first one is that this version uses a single loop and string formatting to generate combinations, making it more efficient for larger digit numbers. And the first code, on the other hand, uses nested logic to update each digit individually, which is better suited for smaller combinations.
Now, let's run the code and see how it works. For example, if the safe has 2-digit combination, the program will generate all combinations from 0 to 99. Let's try it out. As you can see, the program quickly generates all possible combinations. For a 2-digit combination, it takes less than a second, but what if the safe has more digits? Let's try a 3-digit combination. With 3 digits, the program generates 1000 combinations. The time increases, but it's still manageable. This shows how brute force can be effective for smaller combinations. Let's run this code with 3-digit combination to see how it performs. As you can see, this code is just fast for smaller combinations, but its real strength is handling larger combinations, like 10 digits, which would be impractical for the first code.
Brute force methods work for small problems but become impractical as complexity grows. A 4-digit lock has 10,000 possible combinations, which is feasible to crack, but a 10-digit code has 10 billion possibilities, making brute force highly inefficient. If testing each combination takes 1 second, breaking a 4-digit code might take hours, while a 10-digit code could take centuries. This highlights the limitations of brute force and the need for more efficient problem-solving techniques in real-world scenarios.
And that's how you solve the safe combination problem using Python. So we explored two different approaches, one for smaller combinations and other optimization for longer one. We hope you enjoyed this tutorial and learned something new. If you found this video helpful, don't forget to like, share, and subscribe for more programming tutorials. Thanks for watching and see you on our next video. Bye!